So you can tell that I'm jumping a little bit over, like from section to section. It's not necessarily in order the way the textbook has it. And that's just because it works better that way. So here we go. Okay. So for the domain on this particular line, we know that both they end. There's no arrowheads, so we're going to watch out for that. So if we look at our x values, right, we're going from -5 to +5. So it'd be -5 x, and it's always the x values that belong to the domain. Okay, let me just zoom in a little bit. Right, and so x will be between -5 and 5, both included, and then you just do your squiggly brackets like that. I know some teachers in IPR don't require the squiggly brackets, but in applied, it is a must, and it's actually the correct way to do it, so we'll just stick with it, okay? In pre-cal, I think it doesn't, some teachers don't mind, okay? So for the y values, we're also going from -5 to +5, right? If you were to shade in, so it's the same way in this case. Is this a function? Yes, right? It passes the vertical line test. Like there's no instance where you were to draw a vertical line where you would cross it more than once. So yes, it's a function. Question 2. I'm looking at the x values. I'm going from -4 to 2.5, right? So both are included. They're solid. So -4 x less than or equal to 2.5. So we'll go 5/2 like that. The range goes, it's always smallest to largest, folks. You can't miss that. You don't flip, right? It does matter which one. So we're gonna go from -2, and this is y, remember? And it's all the way up to +3. If you go from -2 to +3, right? Those are the two ends of your graphs. And this is gonna, just like factoring, this is gonna follow you wherever you go in the grades to come, okay? The domain and range. Function, is this a function? We do a test and the answer is yes. Always, there's no instance where you go vertical and you cross it more than once, okay? Here we have closed and open, right? So when we look at the domain, which is the x values, you go from -4 to +5. Sorry, turn that off. That's my, there we go. I continue. So we go from -4 x less than, just less than 5. That's the correct way of doing that. Okay. And the range, we go from 1 all the way to 4, right? 1 starts here all the way to 4. So 1 included, but not including 4. Okay. Is this a function? The answer is yes. There is no instance where you cross the line more than once if you were to perform the vertical line test, right? So here we have the domain and the range again of this weird looking graph, right? So you look at the x values, we're going from 0 to 4. Is 0 included? Yes, it is. It's a solid line, right? There's no open dot. So we would go 0, x less than 4. 4 is not included, right? Both of them are open. We couldn't, let's just, for instance, assume one of these was filled. like that. Would you say including 4? The answer is yes, because it does. Here it's included. It may not be included here, but it is included here. Okay, so I'm just preparing you, I guess, extending, right? So these are limit. They have a limit on both ends so far, okay? Then we're going from -2 not including, from -2 to +2 also not including. Okay, so both of these should not have an equal sign. Is this a function? Right there, you just perform it once and it happens there and there. So no, doesn't pass. It doesn't matter where you make that. You don't even need to do that. If I were to ask you, if I asked you to explain, you would have to say, well, when performing the vertical line test, it crosses it more than once. When performing the vertical line test, okay, it crosses more than once. Okay, VLT, that's bad, right? That's gambling. Don't do that. I just came up with it and now I realize, ooh, VLT is not such a good. Anyways, domain for this one, and we go to -5, including, because there's no open dot, to -1, right? So smallest to largest. So -5, and that's x, and that'd be -1 also including. Okay, they're both solid. So notice that it expands, like you go all the way to the left of this graph. This is the furthest it goes to the left. Okay, Dana, got you. We're in our booklets, okay? Try to find this page. I don't have a page number. math8s.com at the bottom there. And -1 is the furthest to the right it gets, right? And both are included. For the range, we're going to go from -2, and it's not included, all the way to, you keep scanning until you hit 2, right? That's the highest this thing goes. And that is included, sorry. That is included. So I hope you're getting the hang of it at this point. Is this a function? No, right? It doesn't matter where, in this case, right? You do that, you cross it more than once, so it's not a function. Domain and range here. We go from x, if you look at the domain, we're looking at our x values. So we go from 0, not included, all the way to keep going, keep going, keep going. You stop at 5. So 0, not included, 5 is, right? And then so that's where you have that. Range, we're going from -3, that's the lowest, all the way to the highest, which is 3. And this is the case that I was talking about. It may be open here, but if you keep going, this is closed. This is a solid. So this is what prevails. As soon as it happens once and it's solid, you would include it. It's part of this graph, okay? So we're going to go from -3 to 3. By the way, this is the sine wave. You're going to see that in grade 12. Yeah, grade 12. Either pre-cal or applied, you see in grade 12. So -3 to 3. And is this a function? The answer is yes. There is no instance where you can draw a vertical line and cross it more than once. Okay. Keep going. Here we go from x, check -5 to -3. Both are not included. The range goes from -5 all the way to 2. Both of them are open, so 2 is not included, but -5 is. Function, no, because right here or on the center, for sure, you'd be crossing it more than once, right? So it's not a function. Here, the domain, we go from -4 to 0, and notice that you have open and solid, right? So solid wins, okay? So -4 x all the way to 0, which is also included because it's solid here. And range is from -2 to +2. -2 solid, right? But the +2 is not included. So that would be just less than. Is this a function? The answer is no, because it, right? Actually, it happens wherever you go, except for maybe one point at the end here, but everywhere else you're going to cross it more than once. It's not a function. All right, I hope it starts to make sense. I'm gonna show you a different way of stating your domain and range today. Some of you might prefer that. And we're also gonna look at open, like if it's open, if it's not a segment like here. It's when you do interval notation, it's a different way of writing it. Okay. Okay, so the domain and range for each graph. Maybe I'll leave some room so that you could do the interval notation later on if you wanted to. So we have x, you would go 4, and then it just has an arrow, right? It just keeps on going this way forever. So this would be x is less than or equal to 4. And that's it. This goes to -infinity here, by the way. Sorry. Let's leave that for now. Let's not put infinities in there. Just leave it like that. But x is less than 4. This is one that is not closed. It's not a segment. It starts and then it goes negative. So x will be less than or equal to 4. Range, y is going to be, you start at 0, right? We're kind of shading this onto our y-axis. We go from 0, and this graph actually is going to keep on going up indefinitely. So y is greater than or equal to 0. Okay, and right, you basically keep going forever this way. And if you were to shade this onto the x-axis, it just keeps on going. Okay. So domain and range. Okay. So here, this is interesting. I don't think I talked about this one. It goes indefinitely on this side and it's indefinite on this side. So it's everything. This is the notation. I'm going to give you a bit more detail that you say that x is part of all real numbers. So watch how I do that real numbers. You draw 2 bars and then you just make that into an R like that. Not that I care if you just write down an R, capital R, doesn't matter. But you're saying that x, all x values along the real number line are part of this graph. All x values are included, okay? So x is part of, that's the symbol for is part of or belongs to, okay? And don't worry, like I have actually the page, we're gonna go back and there's one where I actually tell you what that symbol represents. So when I assigned this, I guess I didn't cover everything just yet. And with range, it's a little different because the lowest you get is -4 and then it just keeps going up. So y is greater than or equal to 4. So range does have, and let me do the domain here. So the domain would be just everything, right? And the range starts here and it just keeps going indefinitely. Okay. And here we have a segment. So it would be -2 not included to 5 also not included. That would be your domain there. And the range goes from 0 not included all the way to 2. See that that's the highest this graph goes. So 0 not included, y less than 2. So we have domain is here, equals to there, open, and the domain is just from here all the way to there, open. Okay. So this is limited, unlimited. This one has just one limit. Okay. Let's keep going. The domain here, again, this continues on forever, right? The arrowhead tells you that this is going to keep on opening up indefinitely. So this is one of those cases where x is part of, it's almost like an E, right? Just a curve like that is part of the real numbers. Okay? Because of this. And range goes from, this would be y is less than or equal to 3, right? Y would be less than or equal to 3 because that's the highest you get. You go, if you scan it, it goes all the way to 3, but that's as high as you get. So y values, the only permissible y values here would be anything less than 3. That would be on this graph. So maybe I'll do range is orange, right? And for the domain, it's just everything, right? And here, it's a segment, so no arrowhead, so we know it's going to have limits on both ends. So we go from -4 for x, inclusive, right? All the way to +4, also inclusive. Okay. For y values, the range, we go from 0 all the way to 5, right? Because that's the highest point. So 0 to 5, both included. So my domain is green, so we're going to go from here to there. And then for the range, we're going to go from here all the way to there. Here we have a limit on one end, but it's open on the other. So you're not going to have two numbers beside it, right? So you're going to look for your x value. The lowest you get is -4, and then it just keeps going up. So x is going to be greater than, but not equal to 4. And y will be less than, but not equal to 3, right? Because all values less than 3 are part of that. So if you weren't able to do these questions after today, you get another go at it. Okay, there's more handouts on this in this package to allow you to practice. Here, my domain, I look at the x values. It's got no limit on one end of the line, right? So x will be less than, right? On the x-axis, it's going to be less than 0. Okay. For the y, it's going to be less than 4, but not including. Okay. For the domain, we go from -4 and it goes all the way to infinity, or it just keeps on going. So it'll be x is greater than or equal to, because it's a solid, -4. And there you have it. For the range, the lowest we get for the y values is -2, right? And then if you think about it, you're like, oh, I'll reach 2, then go down, and then it keeps going up indefinitely. So you got to read the whole line. This tells you that the lowest is -2, but the highest you don't really know because of this. It's indefinite. So, oh, not x, it's supposed to be y. Y is greater than or equal to -2. So watch that arrowhead, right? Those are tricky. For the domain here, the lowest value is -2, and that's not included. And it goes to infinity. So technically this would be correct, but I always like it this way. X is greater than the number. This is preferred. But sometimes you'll read it's like, oh yeah, -2. Oh, it doesn't, it just keeps on going. So that's it. If you think about it, these are saying the exact same thing. Right? Range, it's you go from -3 to +2. -3 to +2, because think about it, this line just keeps going indefinitely to the right, but we know it's going to stay between these two values. Okay, so it's going to be -3 including, but not including the +2. So there you have, maybe I'll just do I will do the domain and range here. I used orange for range. So I go from 3 to 2. And for the domain, I go from -2 to infinity. Should be open there. Okay. Any questions about any of this? Is it a little bit out there? Yeah, it is. But I think once you practice it, you're basically saying what are the permissible x and y values for this particular function or this graph, right? That's what you're really doing. So let's go back a couple pages until you see this handout right here. And a lot of this is going to be repetitive. So you got to go back a couple of pages from the homework until you find this one. And it's still domain and range. Nothing really has changed, except for I'm going to introduce writing it using interval notation. All right. Um, so this still remains. This is less than or equal to, right? We already talked about that. Greater than or equal to. And this is set notation though. This is important. Set notation. And I'm going to talk about interval notation today. And notice that if you have round brackets, so we make a big fuss about round versus square brackets. So round brackets, and these are square brackets. Okay. So if you have round brackets, that is saying that the number, the value next to it is not included. If you have square brackets, then you do include the value that's next to it. And then we introduce infinity. So when you do interval notation, you will have infinity, right? So when the graph, I'll say that when graph has or ends, that's what I'll say. Sorry, I'm making it up as I go. I don't have this in my original. When graph ends with or we use negative infinity or positive infinity. Okay, so you'll see what I mean with this as we go along. Okay. So domain, just another definition, the permissible x values for the function or graph. Permissible is allowed. Okay. The allowed x values for the function or graph. And range is the permissible y values for the function or graph. Okay, so permissible is allowed. I'm looking at this and I'm like, how can I help you if you go back to this, right? This one here, this is the one I was talking about. X belongs to the reals. It could also be Y belongs to the reals like that. We can say Y is part of the real number set. That's another way of it's saying the same thing. But if you see X as part of R or Y, ER, right? That's just saying Y is part of or belongs to the real number set. Like all real numbers. If you think about it, if you remember that, I don't have that on me right now, but the real numbers are basically all numbers that you can possibly think of. Decimals, rational, irrational, right? Like they're all real numbers. So anything goes. That's what you're really saying. Okay. Um, I don't have a lot of room on this here. I don't want to fill this up too much, but I'm thinking this would be a good time to talk about discrete versus continuous data. So that's why I did made this single-sided. So if this is 5.5, just flip back to the one that's right before it. And then we'll just talk about discrete data continuous data. How can you tell the difference between in a graph? If you have a graph like this, no details on this one, I'm just going to give you, if you have something like that, you know it's discrete. Okay? I will try to copy this graph right here on here, but it being continuous now. So I'm going to connect the dots. So let's try to copy it as best you can. It doesn't have to be exactly. Okay? But if I were to connect the dots, that is continuous data. So this would be discrete, this would be continuous, just by looking at a graph. Discrete, how do you know it? Items that can be counted as whole numbers. So examples, coins, cans, people, days, etc., etc. So you can't have half a coin. You can't have half of a can, right? You can't do that, right? So you would be restricted to a graph that is like this. You couldn't connect the dots, right? So sometimes you have continuous along the x-axis, but you have discrete along the y-axis, right? So it gets a little tricky. Things that can be measured. That's how I summarize this. Things you can measure. So height, weight, time, right? Time in seconds, like that. You can definitely count fractions of it, right? 0.5 seconds, that's fine. Money, right? Because you can have $12.35, right? That's all good. And that's all I'm going to say to that. And you'll see as we do the examples, that's how you distinguish between, because it's going to ask you quite often with the data that you're graphing, with the x variable, would that be considered continuous or discrete? So you'd have to look at it and see what makes sense, right? The y variable, is it continuous or discrete? Right? So if you're making money over time, you know both are continuous, right? Time is continuous and money. So if you graphed how much money you make over time, you could definitely connect the dots. It'd be lines, right? Number of people over time, that'd be different, right? How many people are walking through a certain gate, right? Over time, people are not continuous, right? So that'd be, you'd have to use dots there. All right, enough of that. Example 1, determine the domain and range of the following. We're going to do both notations side by side, okay? So I know you're going to get sick and tired of it, but I hope that you'll be able to do it no problem, right? I'm okay with you being sick and tired of it as long as you know how to do it. So domain for this particular graph, set and interval. So let's do the set notation first, because that's what we've been doing so far. So for x, I go from -1 to 3, okay? So -1 not included, x, make sure you use x there, and up to 3. And if your pre-cal teacher next year says, don't use squiggly brackets, then just don't use squiggly brackets, okay? But it's technically not, it's actually the right way of doing it, okay? And then for range, we go from -5, not inclusive, all the way to +3 inclusive. So you're contained on both ends, you have limits. How do we translate this to interval notation? So make sure you have that written down, and then we'll translate. -1 for my x values, right, is not included. So this is what all you do. -1, not included. Remember, a round bracket means it's not including -1. Comma, it's actually easier. A lot of you are going to prefer this. All the way to 3 square bracket. So not including 1 all the way to 3. So you're just basically giving the two values that this graph is found in between. In this case, it's a line segment, okay? And then here we go from -5, not inclusive, right, all the way to 3 inclusive. And that's how you do interval notation. It's that easy. So if you figure this one out, this one is no problem, okay? Let's do this one. It changes, trust me. So we're -4 for the domain. We're going from -4 included all the way to 5 included. So -4, +5, okay? And let's do the range as well right away. We're going from 1, let's scan along all the way to 4, right? 4 is the highest y value. So between 1 and 4, both of them are included, like that. So interval notation for the domain would be -4 square brackets to +5 square brackets. Both of them are included. For the range, both of them are included, so we're going from 1 to 4. Like that. Okay. And now what? You almost forgot about the discrete, right? So when you have discrete, you need to state every single x value individually from lowest to highest. Same with the y. So we're going to go, you cannot do interval notation of this one. So the domain, we're going to go squiggly brackets, and we're going to go -2, 0, 2, 3, 4, so sorry, -2, 0, 2, 3, 4, 6, and 8. That's it. Don't forget about that. That's still there, domain and range. This one would be discrete. Okay. And then for the range, this would be, the lowest is 2, and then we're at 3, and then we are at 1, 2, 3, 4, 5. 5 shows up twice, but you only stated once. Then it's 6, 7, 8. So I'm just going to check. 2, 3, 5, 6, 7, 8. Yeah, we're good. And so, and I always went from lowest to highest. Okay, so it went left to right for x for the domain. I went from bottom to top for the range. Okay. I kind of gave away this question here already. Anyways, so for the domain for this circle, we would go from -3. Sorry, not -3, +3, my bad. +3 to 6, Both of them are included because there's no open dot. That's basically how you know. And then my range, I go from 2 to 5. So 2 to 5. Both of them are included. So it's 3 to 6. In interval notation, just remember it's interval. It tells you, right, from end to end, what's the interval, what's the distance in between. Which of the above are discrete? Graph C. Which one are continuous? Graphs A, B, and D. Anything that's connected like that is continuous. Okay. I'm going to let you do a little bit on your own now. I don't do that very often, but domain and range is one of those key concepts that you need to be able to do quite well. And it shouldn't take you that long. So let's go to that next page there. Do that for now. There are 6 there. Let me just scan quickly. Are you gonna have issues here? No, you're gonna be fine. I'll do soon there'll be arrowheads on one end, but these ones don't. So just do these 6. I'm asking you to do interval and then set. It doesn't matter which one you do first, but I want them both for all of these graphs, okay? So I'll pause here for a bit and go ahead. And here we go. So for this graph, if you want to do interval notation first, I'm going from, in terms of my x values, -4, both are open, right? -4 to -2, that's included. So for the domain, I'd go from -4 round brackets all the way to -2 square brackets. For the range, I'm going from -4 not inclusive all the way to 4 also not inclusive. So it's -4 to 4 round on either end. Okay. For the domain, you basically just translate that, right? -4, right? That because of this is just that, and it's you got to insert the x there, less than or equal to because of that -2. The textbook actually doesn't do the squiggly brackets either. The range, you go from -4 all the way to 4, and both of them would have an equal sign. Sorry, I hope you didn't erase or didn't add. Now you're gonna have to erase if you followed me. Both are just less than because of the round brackets, okay? So maybe I will use yellow for round brackets. Right, so round, and then just highlight that, and I will use orange for square brackets. Right, so every square bracket there, and then again we have yellow here. This would be an open, and so we have that sign there. Okay. Okay. For the domain, for this graph, along the x-axis, we are going from -4 all the way to +4, both included. For the range, we go from the lowest, which is -5, all the way to -1, both included. Square brackets on either end. The domain, therefore, would be -4, right? I use an equal sign there. And then and range is -5, also including, right? So you have to have the equal sign there. So square brackets, and then you have this symbol here, right? Okay. The domain for this graph, it's just a segment as well. We go from -5 all the way to 0, and both not included. Right? So -5 to 0, round, round. And I'm going from -1 for my y, right, all the way to 4, both not included. So your domain would therefore be -5, just that, 0 like that, and then it would be -1, no equal signs anywhere. Okay, you have that. I'll stop highlighting because it'll take too long. So a mixture, the first one had a mixture of both, and the second one is all solid or all square brackets, right? And then we have all open, right? But still, all of these are limited right there. They have an upper and a lower limit. So that's the common denominator here for all of these. Okay, for the domain, I go from -1 to 1. It's included here, but it's not included over here. For my range, I go from 3 all the way to 5, and because of this solid, it trumps everything. So it's 3 to 5, both of them are included. Okay. So the domain would be -1, x less than or equal to 1, right? So that is there, right? Took care of that. So 3 is going to be included, and 5 is also included or inclusive, right? There it is. The domain for this one goes from -4 all the way to +3, both including. The range goes from -2 to the highest point, which is 4, both included. So that will be -4 and 3, -2 and 4. Make sure you include the variable, right? Down the road, it's very possible that there will not be an x and a y here. It could be any variable. That is the variable that goes with you. So the domain always refers to what's on the horizontal axis, and the range always refers to what's on the vertical, okay? And here the domain goes from -5 all the way to +4, not included. Sorry, -5 to +4, round, square. And then for my range, I go from -4 all the way to 5, not included. Not included, but this is included, right? If you need to highlight along the X and Y axis, folks, do it. Okay, whatever you need to do, bring highlighters, do it. Okay. Domain for here would be -5, X is less than 4, and then I have -4 included all the way to 5. Okay. The vertical line test, in case, right, that's short. A graph represents a function when no 2 points on the graph lie on the same vertical line. Go back and identify whether or not the graph represents a function for the graphs above. So we'll do that. Maybe I'll use a highlighter. I'll use green because I haven't used it on this page. But here you have that not a function, right? not a function for this one because it crosses it actually here, crosses it 3 times, right? So not, we'll leave the ones that are alone, right? Yes, yes. Out of all of these, this one would not make it, right? Not a function. So there are two graphs on this, two relations, right? These are still relations, two relations, graphs, right, that are not functions. Okay. Let's do, I need to still address the interval notation when it's arrowhead on one side or both. So hang in there. So let's keep flipping towards the back until you see this page right here. So a couple pages over, it says state the domain and range for each graph and whether or not the graph is a function. We'll just write yes or no. Also state whether the graph is discrete or continuous. Okay, so we're going to do that as well. So is it that, right? Is it a function? And state the domain and range. So we're going to answer all of that here. I will focus on arrowheads a little bit. I'm going to pick and choose. And on this page and the next page, whichever one I don't do, I want you to do for homework, okay? So here we go. I'm going to focus on this one here. And I'm going to circle that actually, right? So domain and range, we're going to do set first. So this would be -4. And it keeps going. So for x values, anything greater than -4 is going to be included, right? So x is greater than -4. That would be the set notation of the domain here. And it's not included, right? So we do that. For the range, the lowest you get is 1. That's included. And then it just keeps going indefinitely up, right? So you're like, hey, what about this, Mr. Dirksen? That's just part of it, right? Like it's just part, but the lowest y value is 1. So it's y is greater than or equal to 1. There it is. And then it just keeps going. Interval notation, this is where it gets tricky, okay? If it's not contained, you will have infinity symbols, okay? You will have. So here we go. You go from -4, not included, right? Just reading the graph, and x will actually go on forever. So you put down a positive infinity on the other end, and whenever there's infinity, you have to use round brackets because you don't know where it ends. You can't use square brackets. It would be incorrect, okay? Always use round brackets when using positive or negative infinity. That's a must. And when you have arrowheads, you will be using infinity at least once. If you have arrowheads on both sides, you'll use it twice with interval, okay? So here for the y, you go 1 is the lowest, that's inclusive, because it's solid here, all the way to positive infinity. In this case, both of them go to positive infinity. Is this a function? The answer is yes, right? There's no point where you can cross more than once. Is this continuous or discrete? The answer is continuous, right? Because you have the lines are connected. Okay, so you've answered all of that now. I guess you can do that right in here if you like, but it doesn't matter as long as you do that. So contained, also contained. Let's skip to this one here, this one right here, center. See, it has two arrowheads, so not contained. I'm thinking if I should make a note. I think I might give you a note tomorrow on that. Just do the homework for now, okay? So for set, right? If it's arrowhead, arrowhead for X, it's this one. X belongs to all real numbers because X continues on indefinitely to both sides, right? This graph just expands, and so all X values are included. Then for Y, in this case, it happens to be the same because, right, it just keeps on, all Y values will be included, okay? So Y also belongs to the real numbers, okay? So it's actually the easiest one to do if there's both arrowheads like that. You got to be careful. I know it's Monday, you're tired, I get it. But if some of you might hear it's like, oh, two arrowheads is always real numbers. If this thing had been pointed up like this and you had arrowhead, arrowhead like that, the y value would have been from here up, right? It's not all real numbers because it doesn't go further down. So watch out for that. Just read it, read your graph and see what makes sense. And so interval would be negative infinity to positive infinity, round, round. Same with the y values, right? It comes from negative infinity and it goes up to positive infinity. So that's the interval notation for being part of the real numbers. So I could ask you, I could just give you, hey, this is the interval notation of the range of a particular graph. What would be the set notation of this? And you should be able to write it next to it. Is this a function? Yes. Right? Doesn't cross it more than once if you do vertical line test, and it's continuous. I think now you're set, okay? So I'll put homework at the top here. If you follow me, I'll go homework up here and homework on the back side. So put down homework. I think I will just leave it at that. I won't do textbook. Actually, this doesn't take that long. Page 294, 4 to 10. Some of them are very short. The book, unfortunately, doesn't do interval. It just does set. So all your answers are going to be set. I still encourage you to write it in interval as well. I will post the key to these two pages by the end of today. So I will not necessarily go through the whole thing tomorrow. So tomorrow I will start ACing you already on everything we've done so far. So go back to what we've done at the beginning of this unit, right? Knowing your input, output, all of that stuff, but primarily on domain and range, right? But you got to be able to find the y value if I give you the x value and vice versa on those functions. So make sure you, could you move the page a bit? Absolutely. Are you thinking of the central there? Okay, there it is.